background to the company, where we're from, what we're doing, what our technology is, and as I say, how we then went through a recent TSB funding project and were successful in that, so to share some of that experience. So from a company perspective, we're a spin-out of Glasgow University, and the word Anacail means shield, preserve and protect in Gaelic. And what's really unusual, we're actually a spin-out of the astrophysics department, and we're now working in food. So that's kind of quite a big leap from where we started, or where we came from, to what we're doing now. But what we have is basically a new technology for delivering what we're calling active oxygen, or ozone, for sterilisation and decontamination issues. So when I use the word sterilisation and decontamination, you realise how we've got into the food sector. But what we've basically got is an IP protected platform across multiple market areas. So packaged food is what I'll go on to talk about in quite a bit of detail in terms of what we do. And there, the early interest from the marketplace in our technology has been about shelf life extension, and that's where our TSB call has been successful in the previous round. And that leads into waste reduction as well. But also there's interest in clean label, of potentially taking out some of the preservatives in food and using our technology to reduce the quantity of preservatives that's in some of the products. But sterilisation and disinfection is a very big, broad market. So going forward, we will also be looking at medical equipment and dental sterilisation, and ultimately there is home use as well. But the early stages of the company were very much focused on food, and that's where I'll go on to spend a bit of time. So ozone has been around for a very long time, ozone, O3, and it's a well-known germicide, but it has been very difficult and challenging to actually use. It's difficult to generate, it's unsafe in large quantities, but it is used in ozonated water for a lot of industrial applications. But what we have come up with is a means of converting oxygen that's inside a sealed bag or a sealed package and converting that to O3. And then that basically acts as a germicide for anything that's inside that package on the surface. So this is not a bulk treatment, it is a surface treatment. And because ozone is an unstable chemical, it decays back into oxygen as well. So that is a great advantage for us. We can create it on demand, we can have the germicidal effect, and then it goes back to oxygen. All of that is done inside a sealed container without any addition of chemicals whatsoever, and leaves no residues. So you can see straight away the potential of a nice sealed package for us is a food package. So this is just a cartoon strip of how it actually operates, and in a second I'll show you a video of it operating for real. But basically, as I say, we start off with oxygen. We take a very small percentage of the oxygen that's in the bag and convert that to O3. So we can actually use just air in the bag, but we also can work with some of the MAP processes that people are using in the food supply chain as well, or the food packaging industry. We create our IPs around the combination of the plasma head design and the package interface, and basically what we do is a plasma head, which I'll show you in a second, comes down to the sealed package and creates a plasma inside the sealed bag, and that converts the oxygen to the O3. We do not break the seal, we do not provide any chemicals into it, we're just converting what's already there. And that converts into O3, and then obviously that kills bacteria, molds, viruses, yeast, which are on the surface of whatever's in the bag. So in that bag could be food, it could be medical instruments, it could be dental instruments. And the great thing about the process, it actually can be repeated if you want. So you can do it now, you can do it in a few weeks' time. So certainly for some of the medical device applications, the repeat ability of it's very good. For the food industry, what you want to do is basically do this immediately after the food has been packaged. So we have, at the early stages of the company, we had built a technology demonstrator, and this is what I'm showing the video of here, so you can actually see the equipment, how it works in practice. So this is the plasma head, the long black bit. This is a standard food packet. This is slowed down in real time, obviously compared to what would be done in a production line. That is the plasma, a little purple bit, and what that's doing is creating the O3 inside the bag. What we'll now do is basically just put a probe into the food package, and obviously this could contain chicken, fruit salad, a whole range of things. And what it's doing is now pumping out what has been generated inside. And what we're just showing here is the quantity of ozone that's created, and this is just integrating over time. So over the next few seconds you'll see this increase, and typically we're getting up to sort of 500 ppm inside the sealed unit. So that's what we had basically at the early stages. We had a laboratory prototype, we had a manufacturing prototype, that's what we call a manufacturing prototype. And what that allowed us to do was go and speak to food customers and actually take the equipment into some food companies and do some trial work on their line, because ideally you want to test this immediately the food is being packaged. So we had to get into food companies to actually do some early trial work. And this here we have an example of, this is actually some laboratory work, where we took some bread muffins, and on one side we have untreated, and on the other side we have treated with ozone. And you can see over time, you can basically watch the mould grow. And the ones on the left-hand side are the ones which have been untreated, and the ones on the right-hand side have been treated. So clearly what we're doing is slowing up the amount of bacteria growth inside the bag, because we've knocked the amount of bacteria on the surfaces right back at the early stages of that. So that kind of early data across a number of different food groups allowed us, as I say, to go and speak to some of the companies involved in food processing. We did some trials, microbiology tests down at Camden and other places to actually test what kind of results we're getting. And we found for E. coli, Campylobacter and other things, we could significantly knock back the bacterial count, and the knock-on consequences of that were then into potential for extending the shelf life. So what was our engagement with the TSB? Now, at the early stages, we were very much an early stage company, typical university spin-out. We had next to no employees, with some good ideas, we had some IP, and we had some enthusiastic people to go out there and make things happen. What we did get to help in the sort of funding side of it was actually a nutrition for life feasibility study, which again helped do some of the early work. And then about this time last year, the food processing manufacturing efficiency call came out. And I attended the equivalent of this meeting last year. Now, as it happened, I sat next to someone from a company, and we got chatting, and before I could even speak later in the afternoon, we'd kind of worked out a bit of synergy in there. And that actually went on to us going into their factory, doing some food testing trials, and they actually came into the consortium we put together for that. So this process does work, and we're a good example of that. So what we did was bring together two of the companies we're already working with, a company we met at one of these meetings, and they were in different food sectors, so we were non-competitive with each other. So we had a bakery company, we had a chilled foods company, and we had a fish processing company. And we led the consortium, which again is a challenge itself when we're a very small company. But we submitted a proposal based on the early stage data we had and the group of collaborators we had for shelf life extension through plasma generation of active oxygen in sealed packages. A bit of a mouthful of a title, but it kind of says what it does. And we went through the whole process of the TSB funding, and we were successful. So it's roughly a 500k project with about 250k grant, which was successful going through the full process. So for us, it was a very key part of our development as a company, and for helping bring this technology to market. So what did we kind of discover or find about the whole process itself? Well, one of the big concerns for us was, as a micro SME actually leading this, but central to the whole what we were doing was our IP and our technology. So we really wanted to lead the project. And it was through discussions with the team here and through these networking opportunities that kind of encouraged us, well, go for it. You're still in micro SME, but that doesn't prevent you from leading, and it doesn't necessarily prevent you from actually being successful. So we, as I say, put together the proposal, and I think one of the key things for us, being a micro SME, was the strength of our collaborators. They were well recognised names, large organisations. So we've got a micro SME working with companies which are sort of $1 billion turnover companies. So getting those very large organisations and micro SMEs working together, to me, was one of the key things that this TSB brought with us. The other thing, we were actually at pre-equity funding stage. So we had spun out the company. We really didn't have any employees at the time. We had growth funding, but not yet seed funding. So that was, again, the benefit of bringing our technology to a wider audience. It also helped us in the funding process for equity funding going forward. We did have early supporting data, and I think that was actually very significant and very important for us being successful in the actual application itself. We had sufficient information to back up the potential of this technology, but there was still very clearly high risks involved in it. And as I say, the credibility of having some large blue chip organisations working with us did help the bid proposal, I'm sure. But there is a lot of paperwork involved. There's no getting away from it. And particularly when you're a really small company, it does seem a lot of work. But you just have to accept that comes with the territory and get on with it. But I have to say, again, going back to KTN, the support we got there, the review process, helping us just, we'd not done something of this funding size for a TSB before, so the review process they helped us with internally, all of that was of great assistance. Going through the stages of the evaluation was quite interesting. I think it was touched on earlier, about 5 reviewers reviewing at each stage. What I wasn't quite expecting was the big diversification of views and anomalies in some of the feedback you get. We had, no pun intended, but one reviewer thought this is the best thing since sliced bread, and another one said this is never going to take off, it's never going to happen. So you get that polarised range of views in that, and the views do change over time. But the good thing is there, the number of reviewers means that you have sufficient broad portfolio of people reviewing it. But don't be expected, if you do get feedback, which is quite contrary in some places. So what was the consequences for us? As I say, some of these customers we were already, who are now our collaborative partners in the project, we were already talking to, but it did help corral what we're trying to do with a number of customers. Basically to get our technology from the manufacturing prototype stage into a real manufacturing environment where this thing is now being used ultimately in a high-speed process, and that's what the TSB will allow us to do, to actually get it into a full manufacturing environment, and for those companies to actually integrate it into manufacturing lines. So it was a key step forward in terms of actually the commercial engagement for us as a micro SME. It did also help with the ongoing equity funding process. We were putting together a business plan, and the fact that the TSB coming through. We did actually close a funding round before the TSB did confirm that they were going to award us this grant, but just the whole fact that we had those collaborations ongoing certainly helped with the VC funding process. But it was something we did have to consider. What if we didn't get it? There was always that risk, and you can never be absolutely sure. Now, if you're a big organisation and you don't get it, well, you tried. But if you're a micro SME at that early stage, what was the potential follow-on issues if we didn't get it? We thought the risk was worth taking. We thought our technology was strong, the collaboration was strong, and we also managed the process to look, if this didn't go ahead, what's the consequences? Thankfully, we were successful. And I would encourage any micro SME to really put together a good consortium and go for it, because it really does help grow your business. So, my lessons learned, as I say, very much don't be afraid of being a micro SME. Now, a micro SME is anything under 10 people. We're 2 people. We've built a very strong consortium with very big blue chip companies. The consortium is good in terms of they're non-competitive. But there are mutual synergies across what they're all trying to do. There is an administrative burden, that just comes with the territory. And for us, the TSB has also helped raise our profile. It's also led into other applications areas as well. People have picked up on what we're doing in the food industry and say, where else could it be used? We've also picked up other grants, a Spark grant, in fact, to do some work with a university, again, which is another interesting collaboration for us. And my key thing is use the KTN. They're a fantastic resource. I don't come from a food industry background. Our founders were astrophysicists, so our network inside the food industry was limited. There are some members in the audience who have also helped us through that networking process. But the KTN is a fantastic resource to helping bring collaborations together. And hopefully I can encourage other people to go for this. I think it's a good help up, particularly for small organisations. Thank you.